The dark side of the moon has never truly been dark. For billions of years, the sun has fired charged particles at the moon. But new samples suggest it has been exposed in a very different way from the other side we know, and the two have not been living in the same weather. And our Earth may be the reason. Shall we peek behind the story? In June 2024, China's Chang'e 6 mission returned 1,935 grams of regolith, the dust and rock covering the surface, from the lunar far side. These are the first samples brought back from the hemisphere that never looks at us. The moon has no substantial atmosphere, and, for most of its history, no global magnetic field. Solar wind therefore reaches its surface directly, implanting particles within grains of lunar soil, particles that Chang'e 6 allowed researchers to investigate. In July 2026, a team led by the Institute of Geology and Geophysics of the Chinese Academy of Sciences measured the noble gases inside the Chang'e 6 samples. Because these gases are chemically inert, they can trace the physical journey of the solar wind. The researchers compared the Chang'e 6 samples from the far side with material returned by Chang'e 5 from the near side in 2020. The researchers analyzed 7 portions of soil. 4 were heated to progressively higher temperatures, while 3 were completely melted. In the far side samples, krypton and xenon were released mainly at higher temperatures than in the Chang'e 5 samples from the near side. This shows that solar wind particles had penetrated deeper into the far side grains. Fancy a deeper look? Normal solar wind travels at roughly 400 kilometers per second, but when the moon crosses Earth's magnetosheath, part of that flow slows to around 200 kilometers per second. During 2 crossings in each lunar orbit, the Chang'e 5 side receives this slower wind. Slower particles penetrate less deeply. At the Chang'e 5 landing site, on the near side, this slower stream affected about 1/4 of the solar wind irradiation time. The Chang'e 6 site, on the far side, was unaffected by it. The result suggests that Earth's magnetosphere helped create a hemispheric difference in how deeply the solar wind penetrated the lunar soil. And the moon was not done with us yet. It held another surprise. The neon isotope signature differed from every near-side sample studied so far, and existing models do not yet fully explain it. Meanwhile, the krypton and xenon preserved in lunar soil may hold a record of how Earth's magnetosphere and the solar wind interacted over time. How much of Earth's magnetic history is still preserved in the lunar soil? 2 sides, 1 moon, and only one has ever known what it means to have Earth in the way.